We're fixing to take everything we know about the unit circle and write it as a table of values. So I want you to think about the amount that we are rotating as the x value, right? Those can be things I plug in. And then what I get out as the output is going to be the y value. And I'm going to have an x and a y that we are then going to graph on a coordinate plane, right? With the x representing theta and the y being our output. So we're going to start with cosine. I always start with sine, but that's okay. So cosine of 0. Do we know that value? Cosine is the which value? Cosine is the x value. So if I've rotated nowhere, what is the x value? 1. Cosine of pi over 6. So that's a 30 degree. Do I need to draw it out every time? That's a 30 degree reference angle. So if this is 30, the opposite is 1, which means the adjacent is radical 3. The hypotenuse is 2. It is not. Cosine is the adjacent over the hypotenuse. So it would be radical 3 over 2. Cosine of pi over 4 is radical 2 over 2. Cosine of pi over 3 is 1/2. Cosine of pi over 2 is 0. Cosine of 2 pi over 3, negative 1/2. I move to the second quadrant now. Cosine is negative. Cosine of 3 pi over 4 would be negative radical 2 over 2, 5 pi over 6. Negative radical 3 over 2. Cosine of pi is negative 1. Right, then you see we could keep doing this and keep following this pattern. So like what would be cosine of 7 pi over 6? Like they skipped it, but we should know what it is. 7 pi over 6 would be negative radical 3 over 2. 5 pi over 4 would be negative radical 2 over 2. 4 pi over 3, negative 1/2. And then they get to here, cosine of 3 pi over 2. That's 2. We're going to rotate to the negative y-axis. We're back to 0. And again, fill in the gaps, but we know what it should be. Right? It would go 1/2 to radical 2 over 2 to radical 3 over 2 to 2 pi. We're back to 1. Okay, so let's graph that. So at 0, when I've not rotated anywhere, cosine starts with a y value of 1. So I'm going to put a little tick mark here. Let me know this is 1. And it looks like the lowest we go is negative 1. So if I'm at 0, 1, and then at pi over 6, I should be at radical 3 over 2. Put that in your calculator to get us a decimal approximation. Should be 0.807. 0.866. Well, that's close, kind of. 0.866. So we're going to be right about here. What about next point? Pi over 4, radical 2 over 2. So radical 2 over 2 is 0.717, 707, 717. 07, dang it. Okay, so that's a little bit lower. What about at pi over 3? That's a half. Do we know what a half is? You need to use your calculator. Decimal representation? No, let's hopefully know what a half is. 0.5. And what about at pi over 2? So this graph is going to look something like this so far. So it's not a straight line. Not a straight line. Should be curved. Then at 2 pi over 3, we're at negative 1/2. Then we're at negative 0.7. Then we're at negative 0.86. And then at pi, we're at negative 1. So the graph has some characteristics that are kind of similar to a parabola, right? It's kind of a curved line. It's kind of rounded, not straight. So we've talked about switching concavity from concave up to concave down. Right? Remember, concave down was like an umbrella. Concave up is like a bowl or a U. So when we first start on this graph, which do we have? The graph starts as concave down, and then once we get to 0, it switches to concave up. So this is a point of inflection. Is that what we call it? Point of concavity? I don't remember what they used last semester. They're both the same. And so here we're concave up, and then it's still going to be concave up at 7 pi over 6. So here's where we talked about it mirrors this one, right? Even though we didn't fill those out, 7 pi over 6 would be at 0.8. 5 pi over 4 is 0.7. 4 pi over 3 is 1/2. And then 3 pi over 2, we're back to 0. So this graph is concave up the entire time. And then it starts becoming concave down until it reaches its maximum back at 2 pi, where it's all the way back up to 1. I think they should be the same. Mine may be a little off, but that's the same height. And so, is this the end of the graph? Like, can I rotate more than 2 pi? What would happen if I kept going? The same thing over and over and over, right? You ever seen like a representation of like radio waves or X-rays that send out a signal? That's what that is. It's a sinusoidal wave. So we can call them sinusoidal, or we can call them periodic, right? Because there's a cycle that's happening over and over and over. We'll use both those words interchangeably to describe the graphs. So let's talk about them. What is the domain of this graph? Domain is the list of all possible x values. By default, the domain is always negative infinity to positive infinity. What are the two reasons that we wouldn't have negative infinity to positive infinity?
I remember what it is. I don't remember a hole.
Well, we could have a hole that happens, or we could have... Right, so that's what we're getting. That's the way we explain it. You are correct. Domain errors show themselves as either holes or vertical asymptotes. That's what they look like graphically. Algebraically, we get those by either dividing by 0 or... What's the other thing we're not allowed to do?
Taking the radical square root of negative.
Square root of a negative, right? No divide by 0, no square root of negative. Does sine divide by 0? No. Does sine take a square root of a negative? No. Can you think of any trig functions that might do either of those things? Could we ever get a divide by 0 in a trig function?
Hope not.
Yeah, tangent. Yeah, cotangent. Yeah, secant. Yeah, cosecant. Right? Because remember, secant is the reciprocal of cosine. We could get a value of 0 for cosine. So the reciprocal of secant would be, but again, we're not getting there yet. Just know that sine and cosine, the domain is negative infinity to positive infinity. There is no divide by 0 in either one of those. Next, what's the range? So what's the lowest y value the graph will ever take on? Negative 1. Does it actually touch negative 1? So we put a brace, right? To show that it's, or a bracket. I can't remember. Still can't remember. I think it's a bracket, isn't it? Whatever. Just leave me alone. Okay? What's the highest y value the graph takes on? Bracket. It actually touches 1. Okay, all these other concepts, and we'll learn more of them, more besides these. These are specific to periodic functions or sinusoidal functions. Amplitude. Does that not just give you that same radio wave feeling? The amplitude of the wave, how high, because I got different frequencies. Anyways, amplitude means basically, so I'm going to use some terminology that your Northeast assignment will use. They use what's called the midline. I'd never heard that before I did. And again, remember, these are new 113 assignments. On the old 113, they never use that term, midline. But this does on my open math. So if you think about the x-axis as being the midline, because from here, the y values go up 1 and they go down 1. And this is the value that's right in the middle of those, the midline. Okay? So the amplitude is really the distance from the midline to the highest point, or from the midline to the lowest point. Okay, so here the amplitude of cosine is 1. Another point of reference, amplitude can never be negative. Amplitude is always positive.
Yeah, we've done that.
You've done amplitude? Okay. In Cal 2? I mean in Algebra 2? Okay. Sorry.
I was like, yeah, we took calculus. We're not struggling with this
Yeah.
much whatsoever.
Yeah, okay. Symmetry. Is the function even or odd? So, symmetry means we have, I'm sorry,
Flip it over the y-axis.
if it will flip over the y-axis, it's which one? Even,
If
right?
you flip it all the way over and it looks the same as
Right, if you can flip it over the origin, it's odd. So in order to be able to flip it over the origin, it must go through the origin. So that's not the case here. If you think about it, if I were to mirror this, is that what the graph would look like? Yes, it would. So if I were to flip it over the y-axis, that is actually what we would get. So cosine is even. Okay, the next thing we want to talk about is the period of cosine. So what that means is, how long does it take for this cycle to repeat itself? 2 pi. Once I get back to 2 pi, I'm going to draw the same thing over and over and over. So the period is 2 pi. Next, intervals of increasing. So I want to know, on what intervals is this graph increasing? So starting here at 0, remember we read from left to right. What's it doing immediately? Is it increasing or decreasing? Decreasing. When does it stop decreasing? Pi. Stops decreasing at pi. And then from pi, it starts increasing until when? 2 pi. So this is increasing from pi to 2 pi on its main interval, right? It says here, this is important, restrict the last 4 questions to only be the numbers between 0 and 2 pi. Because is this the only place it ever increases? No, because it's going to decrease until 3 pi, and it's going to increase from 3 pi to 4 pi. And it's going to decrease from 4 pi to 5 pi. You see, I couldn't list them all. So, because it told me only between 0 and 2 pi, that makes sense. Also, remember, increasing, decreasing, we never include the endpoints. Because at pi, That's where it switches. It can't be decreasing and increasing. So we never include the endpoints for increasing, decreasing. Similarly, we just talked about where it's decreasing. Hopefully I don't have to spend too much time there. Decreasing from 0 to pi. And then we've kind of already talked about this. Where is it concave up? So immediately the graph is concave down. When did it switch? Pi over 2. So it starts being concave up at pi over 2. When does it stop being concave up? 3 pi over 2. Which means where is this concave down? Well, from 0 to pi over 2. And, so how do you say and? The union. 3 pi over 2 to 2 pi. So filling them out, what is sine of 0? Sine of 0 is 0. You remember sine is the y value. When I've rotated nowhere, the y value is 0. Sine of 30, 1/2. Sine of 45, sine of 60, sine of 90, sine of 120, sine of 135, sine of 150, sine of pi. So this one's unique because it's positive in both those, right? And then what's fixing to happen now? As we go to the third quadrant, sine's fixing to become negative. So it's going to follow this pattern, negative 1/2, negative radical 2 over 2, negative radical 3 over 2, until we get to 3 pi over 2, where sine is going to bottom out at negative 1. And then it's going to start its climb back up. When it gets to 2 pi, it'll be back to 0. All right, so if I graph this, I'm at 0. I'm at 1/2. I'm at radical 2 over 2, radical 3 over 2, and I'm up to 1. And then I'm back down till I get to pi. Then at 3 pi over 2, I'm at negative 1. And then at 2 pi, I'm back to 0. So again, what's going to be my domain of my sine wave? What's my range? Those should be in brackets because it actually touches negative 1 and 1. Amplitude.
1.
Any symmetry?
Yes.
Yeah, it's odd this time. It goes through the origin. So that means it needs to be the opposite on the other side of the origin, and it will be. It will be going down here where it was going up there. So the sine function is odd. What's the period? Takes it 2 pi to repeat itself. Where is it increasing?
0 to 1/2 pi.
0 to 1/2 pi.
3 over 2 pi.
So union 3 pi over 2 to 2 pi. Right, we're going back up again, increasing. So where's it decreasing? From pi over 2 to 3 pi over 2. Remember, decreasing just has to be going down. Okay, next, where's it concave up? So this graph starts being concave down. When does it stop being concave down?
Pi.
At pi. Pi it switches to be concave up. When does it stop being concave up?
2 pi.
2 pi. So this is concave up from pi to 2 pi. And it is concave down from 0 to pi. Does anyone recognize this? No, it's not information.
X-axis?
So this would be a negative on, so that's not the way I was explaining it, but you could. Negative on the inside is a reflection over the y-axis. What did we just get done talking about that was a reflection over the y-axis? An even function. This is how you determine if a function is even or not. If you plug in negative for x, and you get the exact same thing back out.
So it's true.
It is true for cosine. You may show you another cool way to explain how. Watch this. Watch. Okay. So let's pretend like I rotated 30 degrees. Okay. Well, 30 degrees, that would be right up there over 2. What if I rotated negative 30 degrees? It says a 30-degree reference angle. So it's still going to be, and because I'm in the 4th quadrant, cosine is, so even though I plugged in a negative x, I still got the same y value I did if I plugged in the positive x. And if you think about, just focus on cosine, cosine's positive, negative, negative, positive. So if I rotated to the positive or negative, they're both positive, they're both negative. They're both negative, they're both positive, both positive, both negative, both negative. You follow that? No matter which. It's cool when you start putting all that stuff together like that. Maybe it's not cool. Okay, maybe I'm uncool. Okay, whatever. You see why it doesn't work with sine? All students take calculus. If I rotate in opposite directions, it's positive here, but it's negative there. Positive, negative. They never matches up. I'm not looking at the other trig functions yet because they've got their own surprises that are coming. Okay, anyways.
What is?
Cosine, does it have a y-intercept at 1?
Yes.
Yes. Was there another one of these you had a question about?
The x-axis represents the cosine ratio. Like, what does that even mean?
I have no idea. The x-axis represents the cosine ratio. No, it's the y-axis. So, remember, x is our theta. That's how much we're rotating. So the y represents the ratio. Like, if I rotated nowhere, cosine is 1.
Yes.
So the ratio is the y.
Are they just trying to trick us because we know that cosine is x?
No, not necessarily. If you look at those notes that they did, remember they drew those arrows to y and said it's the cosine ratio, and they said x was the angle. That's what they were getting around to.
Not the last one.
So can I have, so if x is negative, right, is all this is saying. If x is negative, does that make cosine undefined?
No.
No, I just rotate the other way. Remember that graph goes both directions forever.
What does that one mean?
Cosine is never undefined anywhere. Which one?
The one, f of 146 pi.
So this means if I rotate 146 pi's, where would that put me? At any even number of pi,
It would be a good
we're back to the positive x-axis, right? Because this is pi, this is 0, 1 pi, 2 pi, 3 pi, 4, 5, 6, 7, 8. So even pi puts me as a positive x-axis. On the positive x-axis, cosine is 1.
one.
True.
Is it negative 1? It was 145.
Yes, if this was an odd number, it would be negative 1. If it was something over 2,
It would be on 0.
zeros.